Hello everyone, my name is Komasinyolo. Welcome to another video by Attention Matrix, where we try to make learning fun and easy. Please comment, like, and subscribe if you would like us to continue making this content and you enjoy it or find it helpful. Now on to the next video. Let's get right into it. Okay, so in this lesson we will be looking at arithmetic series and what makes an arithmetic series an arithmetic series, and what makes it non-arithmetic. I will go through a couple of examples illustrating what is arithmetic, what distinguishes an arithmetic series or a sequence and a non-arithmetic series or a sequence. Okay, I realized that in the first lesson I did not do that. I will make up for that in this lesson. Okay, so let us get our pen and get started. Okay, so in this lesson we will be focusing on arithmetic series. Okay, arithmetic series. And I will explain a couple of more things on arithmetic sequences that I did not get to explain on the first lesson. Okay, so let's say you've got an arithmetic sequence. Okay, so here's your sequence. We did our sequences in the first lesson, but let's use the same example that we used in the first lesson. So here's our sequence. Our sequence is 2, 2, 2, 2, etc., etc., etc. Okay, so here's an arithmetic sequence for you. This sequence is made up of 2's. Okay, it's made up of a bunch of 2's. Okay, so now a series is simply an addition of the terms of a sequence. Okay, so if you've got a sequence and you decide to start adding the individual terms of the sequence to each other, all the terms to each other, then you have what we call a series. You have what we call a series. So a series of the sequence that you see above here would be 2 plus 2 plus 2 plus 2, etc., etc. Okay, so the difference between a sequence and a series is essentially a semicolon, and a plus sign. A semicolon and a plus sign. That is the difference. Okay, for a sequence you list the individual terms and you don't add them together, and for a series you add the individual terms. Okay, so that's what distinguishes the two. That's the difference between a sequence and a series. Now, what is an arithmetic series? Okay, remember what an arithmetic sequence is. Just to recap, an arithmetic sequence, if you've got a sequence 2, 2, 2, 2, and 2, and etc., you've got a bunch of 2's, and you've got all these terms here listed here, and then you've got the first term being term 1, second term being term 2, third term being term 3, fourth term being term 4, fifth term being term 5, and this goes on forever. Right. The difference between the two terms has to be constant in order for this thing to be arithmetic. Okay, so 2 minus 2 is 0. So D is 0. 2, this 2 minus that 2 is 0. This 2 that you see here minus this 2 here is 0. And this 2 here minus this 2 here is 0. Since all the differences are zeros, then this is what we call an arithmetic sequence. Okay, that's what we call it, an arithmetic sequence, because the differences are the same. Now, what if the differences were not the same? What if the differences were not the same? Well, if the differences were not the same, if we had 2 and we had 4 and we had 5 and we had 7 and we had 11 and we had 16, just a bunch of random numbers that I'm making up in my head. Now, T1 in this instance is 2, right? That's T1. T2 is 4. T3 is 5. T4 is 7. T5 is 11. T6 is 16. Now, what is the difference between the successive numbers, the numbers that follow one another? What is the difference? Well, let's see. The difference between 4 and 2. What is 4 minus 2? 4 minus 2 gives us 2. So T2 minus T1. T2 minus T1 gives us 2. What is, let's change the color here. What is T3 minus T2? 5 minus 4. 5 minus 4 is 1. We can already see that these differences are not the same. So this is not arithmetic. If we proceed further, just to illustrate the point some more, if we proceed further, you will see that 7, for instance, minus 5 is 2. Now, just because this 2 and that 2 are the same does not mean this is an arithmetic sequence. It's not, because all of them have to be the same. If just one is not the same as the other ones, then this is not arithmetic, and you cannot use any of the formulae that we give you to use for your arithmetic sequences. Okay, so this is not an arithmetic series, and you are not allowed to use any arithmetic formula that we give to you to use. Okay, so this is an example of what is not an arithmetic pattern or an arithmetic sequence. Okay, now going back to arithmetic series, because this is the main topic of this lecture. Let's select a black pen there. Going back to the main topic of this lecture, this is a lecture about arithmetic, AR for arithmetic, right? Arithmetic series. Now, let me just think of a random arithmetic series. Okay, I'm going to think of a random arithmetic series, and then we are going to solve it. Remember, the difference between a sequence and a series is a plus and a semicolon. Series have plus signs between the terms, and sequences have a semicolon. Sometimes they use commas, but the right one to use is semicolons. That's the difference between a series and a sequence. Okay, plus for series, semicolon for sequence. Okay, so now let me come up with a random series. Let's say I've got 3 plus 6 plus 9 plus 12 plus 15 plus etc. Okay, now this is, how do we know that this is an arithmetic series? Well, the first thing, do not forget, the first thing to always look at to determine if you're dealing with an arithmetic, whether it's a series or a sequence, is to find the common difference between the terms that are given to you. Find the common difference. The common difference is D. Remember, this is the first number, it's T1. This is T2 is 6, T3 is 9, T4 is 12, T5 is 15. Okay, now, let me just move this up. What is the common difference? What is the common difference between all of these numbers, between two successive numbers? Remember, if the common difference D is the same for all successive numbers, all of them, then this is arithmetic. If just one common difference is not the same, if it's different, then this is not arithmetic, and we're not allowed to use any arithmetic formulae. Okay, so now, what is T2 minus T1? T2 is 6. T1 is 3. Okay, T1 is 3. So what is T2 minus T1? What is T2 minus T1? Well, T2 minus T1 would be 6 minus 3. Even though you see plus signs there, you can ignore the pluses for now. The only thing that the pluses are telling you during this process is to tell you that this is a series and not a sequence. Don't use them just yet. We will use them during the course of this video, where we actually do start adding stuff. So 6 minus 3 is 6, okay? And what is T3 minus T2? T3 minus T2, T3 is 9, T2 is 6. 9 minus 6 is 3, okay? And then what is T4 minus T3? Well, T4 is 12, T3 is 9. 12 minus 9 is 3. Okay, and T5 is 15. T5 is 15. There's your 15 there. And then T4 is 12. What is 15 minus 12? That's 3. All these D's are the same. So we know that we are dealing with something that is arithmetic here. This is arithmetic because the D is the same between all the successive terms, all of them, you get 3 each time. Remember earlier on we got different D's, and then we established that we were not dealing with an arithmetic sequence. So in this instance, we're dealing with something that is arithmetic because all the common differences are the same. Okay, now let's move this away. I'm going to stick to the same sequence, or to the same series, sorry. I keep mixing the two up. This is a sequence, so I've got 3 plus 6 plus 9 plus 12 plus 15, etc., 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 plus, 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 plus. Now, a series just tells you that you have a sequence. The sequence is made up of terms. Take all those terms and add them up. Okay, that's what a series tells you. So, if I were to tell you that I want you to add up all the terms of the series up to a certain point, then you would tell me, let's say for instance, I want you to add up the numbers of this series up to 15, right? This T is 3 is T1, 6 is T2, 9 is T3, term 3, 12 is term 4, and then 15 is term 5. Now, what if I were to tell you that I would like you to add up all the terms of the series up until 15, up until term 5? Well, how you would express that, or how I would express that, is I would ask you to do the following, right? Let's say I say S. And remember when we were dealing with sequences, we were dealing with Tn, right? In this instance, we're dealing with Sn. S simply means sum, okay? The sum of the first n terms. This is what this is telling you. So the sum, this is the sum of the first n terms. Now, what do I mean by this? I mean the following, okay? Let me just erase this thing down here. The sum of the first n terms. This is what I mean. I mean, if I say I want you to add, or to give me the answer to this S5. Okay, I know my 5s look like S's. If I say I want you to give me the answer to S5, this simply means that I want you to give me the answer I would get if I were to add the first 5 terms of this series. Now, if I scroll up there, what are the first 5 terms? The first 5 terms of this series here are 3, 6, 9, 12, and 15. T1, T2, T3, T4, and T5. Okay, T5 is my 5th term. That's where I stop. Now, what this S5 is telling me is that take all of the first 5 terms and add them together and stop there. Stop at term number 5. So if there's term number 6 and term number 7 and term number 8, you stop. You ignore them. Just focus on the first 5 terms. Okay, so what are the first 5 terms for this series? Well, the first 5 terms for this series are, let us identify them. They are 3, 6, 9, 12, and 15. Okay, 3, 6, 9, 12, and 15. Now, what do I get when I add 3, 6, 9, 12, and 15? This is 3 plus 6 plus 9 plus 12 plus 15. Okay, then I'm just going to scroll down to make room for myself. What do I get? Well, this is what I will get. I have S5 is equal to 3 plus 6 is 9, right? 3 plus 6 is 9. Then 9 plus 9 is 18. Then 18 plus 12 is 30. Then 30 plus 15 is 45. So the answer to this would be 45. That's all that it is, right? S5 just tells you to add the first 5 terms of this arithmetic series. And how do we know that it's arithmetic? Because the common difference D for all the successive terms is the same. And that's all you do. That's the answer. Okay, let's do a second example. Let's do it quickly because I've explained the concept sort of in detail now. So let us do it this way. Let's say I've got another series 4 plus 7 plus 10 plus 13 plus 16 16, right? Okay, and then I tell you to give me S3. What is S3? Well, first of all, if they don't tell you that this is arithmetic, right, you can check it yourself. How do we check that it's arithmetic? Well, the difference between two successive terms should be the same. So I'm just going to do that quickly now. Two successive terms, successive meaning they follow each other, right? So 7 minus 4 is 3, right? 7 minus 4 is 3. You don't have to do this. I'm just doing it because I'm explaining. If they tell you that it's an arithmetic series, you don't have to do this check, right? 10, what is 10 minus 7? 10 minus 7 is 3. What is 13 minus 10? 13 minus 10 is 3. What is 16 minus 13? 16 minus 13 is 3. So the common difference are all the same. This is D, 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 right? All of them are the same. So we know that we are indeed dealing with an arithmetic pattern. In this case, it's a series. Okay, I'm just going to write out the series again. I'm going to write it out again. I had, what did I have? I had 4 plus 7, right? Let me write it out more neatly. I had 4 plus 7 plus 10 plus 13 plus 16, etc., etc. And I asked you to give me S3. What does this mean? This means that I want you to take the first three terms, right, and add them and give me the answer. Now, 4 is T1. There is T1 there. 7 is T2. 10 is T3. That's where I want you to stop. S3 means stop at term number 3. Now, what is the sum of the first three terms here? Well, you've got 4 plus 7 plus 10. Okay, what is 4 plus 7? That's 11, right? What is 11 plus 10? That's 21. Right, so the answer then to this question, S3 is equal to 21. S3 is equal to 21. S3 is equal to 21. And that is your answer. Okay, now, just like for arithmetic sequences, what if, just like I explained it for arithmetic sequences, what if you've got like a lot of terms, right? I'm just going to use the same sequence again. Let's say you've got a lot of terms. You've got 4, right? Plus 7 plus 10 plus 13 plus 16 plus, what is it, 19 plus 21 plus all the way to whatever, right? And then they say to you, hey, Mr. Guy, here's what we want you to do. Or here, Mr. Lady, we want you to find S76, right? What does this tell you? What does this tell you? Well, this is saying we want you to calculate the sum of the first 76 terms of this arithmetic series, right? We want you to write out the first 76 terms, right? You keep adding 3 up until you get to, because 3 is the common difference, you keep adding 3 up until you get to term number 76. Once you get to term number 76, then you take all those terms up to term number 76 and you add them up. Now that's going to take the entire day, right? Or not the entire day, but it's going to take a bit of time. It's going to take a long time for you to achieve that. Now we need a shortcut. How do you do that? How do you achieve that? How do you get to add the first 76 terms without actually having to add all the individual terms? Well, it turns out that in order for us to do that, we have a formula. By the way, the formulae that I'm giving you for these arithmetic series and sequences can all be derived, right? I'm not going to do the derivations. We might do them in a later video, but I'm not going to do the derivations now. They're quite simple derivations, actually. Right, so the formula for an arithmetic series, remember it has to be arithmetic for you to use this formula. If it's not arithmetic, if the common difference D is not the same, then do not use this formula. Do not use it. Okay, so Sn, it turns out, is A divided, what is it? It's not A, I'm lying. It is N, right? It is N divided by 2, and then you've got 2A plus, you don't have to memorize these things. I used to memorize them in my head, but now see I'm forgetting them. I have 2 copy them down. I have it next to me here. Okay, so this is the formula. You will get this in your formula sheet. You should get it in your formula sheet. The important thing for you to do is to understand this formula, what it means. Right, just like for your arithmetic sequences, you've got different variables in this equation. Each variable stands for something. You must understand what each variable stands for in order for you to be able to use this equation. Okay, so that's what I'm going to explain. I'm going to explain what each variable means. So in this equation here, let's say you've got a here. There's a there. A doesn't change. A is the first term, right? First term of the series. Okay, same as for sequences. The first term. D is the common difference. Same as for your sequences. Common difference. Excuse my handwriting. Common difference. N is just the position of the term that you're looking at. It's just the position of the term that you're looking at. And remember, just as for sequences, this n here and that n there should always be the same. They should always be the same, right? Now this is the formula that you must use. Oh, and this n here. So as long as you see an n, all the n's must be the same. This must be the same as well. Okay, so you know what all of these things stand for in this equation. Now let's actually use the equation. Okay, so I'm gonna rewrite the sequence again. Oh, sorry, the series. So I've got 4 plus 7 plus 10 plus 13 plus 16 plus 19, etc. Right? Etc. 19, etc. Okay, so remember what the goal was. The goal was to find S76. Was it 76? Let's see, scroll up there, S76. Okay, so let's find what S76 is. Okay, so the first thing to do is to write out the formula. Firstly, what is 76? 76, remember the formula, remember what the formula looks like. If I scroll up there, the formula is Sn, right? Sn. N is our subscript there. It just simply means the n, the subscript of S, which is n there, simply means that wherever you have n, you substitute n. So whichever number I replace with n is going to be the number for the rest of the other n's in the equation. Okay, so if I've got 76, then n is 76. That's all that it means, right? So you've got, I'm actually gonna, it's a good idea to actually write out what you have before you start solving. So n is equal to 76 because that's what we're looking for, right? What is a? Now, if you remember properly, our a from our series was 4, right? If I scroll up there, here a is the first term and our first term is 4, right? Our first term is 4, so a is 4 because our first term of the series is 4, right? And then d, remember what our d is? Our d is simply the difference between two successive numbers. It could be 10 minus 7, that's 3. And it has to be the same. 13 minus 10 is 3, right? 16 minus 13 is 3. So we confirm that this is arithmetic. We confirm that we can indeed use the arithmetic formulae. Okay, so d in this case is 3. Now all we have to do, we've got everything that we need for us to be able to use this equation. We've got a, we've got n, and we've got d. So we can solve S76. We can solve for S76. What is S76? Well, S76 is equal to 76. Where we have n, we write 76 divided by 2. We open our bracket, and then we've got 2 times a. What is our a? Our a is 4, and then we've got plus, open bracket. What is our n? N is 76. I'm just substituting stuff into that equation. Then minus 1, close bracket, then d is 3, then close bracket. Okay, so now we can solve. You can take your calculator and punch this in, or you can solve it using your big brains that I know you have. So what is 76 divided by 2? This is going to give you 38. Okay, and then this is going to give you 2 times 4 is 8, and then this is going to give you 75. And then this is going to give you 3. Okay. And then you continue solving. I hope I did not make an arithmetic mistake. Let's see, I continue solving. Then we've got 38. This is outside our brackets. Then this is 75 times 3. What is 75 times 3? So we've got plus 75 times 3. 70 times 3 is 210. 5 times 3 is 15. 210 plus 15 is equal to 225. So this is 225. Okay, this is 225. Then you've got 38. Then you've got 8 inside here. 8 plus 225. I'm not repeating myself now. 8 times 225. Make sure you've got your calculator when you're doing these things. 25 plus 8 is 33. So this is 233. So 233. 233. And finally, let's do this. Let's move this up. What's 38 times 233? Let's see if I can quickly grab my phone so I can do this calculation. My calculator is far away, so let's do this calculation quickly. We've got 38 times 233, that's 8854. Okay, that's 8854. So this is S76. The sum of the first 76 terms of this series is 8854. 8,854. And this is S76. What does this mean? This means that if I say term 1, right, plus term 2, plus term 3 for the series that we're working with, plus term 4, plus term 5, term 6, term 7, term 8, term 9, term 10, term 11, up until term 76. If I take all those numbers and I add them up, then I will get 8,854. Okay, what does this mean? For more context, just so that it's absolutely clear, this means that 4 plus 7 plus 10 plus 13 plus 16 plus whatever number comes after, plus all those numbers up until we get to the number that we get when we get to term 76, then the answer that we are going to get is 8854. Remember, 4 is T1, 7 is T2, 10 is T3, 13 is T4. We're going to have to keep doing this up until we get to whatever number we get to by the time we get to T76. We're going to have some number here. And then when we take all the numbers before this number all the way to the very beginning, we are going to get the answer we got from that equation, and which is, that equation is 8854. Okay, now this is one way of solving this sequence. Now, what if you had term number 76? What if you actually had term number 76? So this is 4 plus 7 plus 10 plus 13 all the way to term 76. What is term 76? We can use our equation for arithmetic sequences to find out what term 76 is quickly. I just want to show you something. So term 76 is equal to A, which is 4, plus 76 minus 1. This is an equation from the first video. Okay, times 3. I'm just substituting things now. I'm doing it quickly because I want to show you something with a different equation. So A is 4, right? A is 4. Okay, so we know that 76 minus 1 is 75. 75 times 3, I calculated this before. 75 times 3 is 225. 225, and then this is 4 here. So we know that 225 plus 4, 225 plus 4 is 229. Okay, so 229 is term number 76. Term number 76 is 229. Okay, it's 229. Now, there's a different equation that you can use to find out the summation of the first 76 term for this series. Now, the second equation that you can use if you don't use the first one will work, but you can, if you don't want to use the first one and you want to use a quicker one, this is the one that you should use. Sn, if you have the first term, right, if you have the first term and the last term, then you can say n divided by 2, then first term, this is A, and L for last, right? This is your last term. This is a different form of the equation that you can use. Now, what we just saw up here is that the last term, term number 76, is 229, right? This is 229. So we know that our last term is 229. This is all that is. This is 229. The first term in this case is 4, right? Now, how do you find S76? If N is 76, L is 229. Just by the way, we're dealing with that thing there. So S76, right, is equal to N, which is 76, divided by 2, open bracket. Your first term is 4. Your last term is 229. Now, if you take your calculator and you punch this in, let me just confirm my answer to make sure that I didn't make an arithmetic mistake in the first instance. 76 divided by 2 is 38. 4 plus 229. 233. 8854. Yeah, okay, so I didn't make a mistake. So what you will see is that if you take your calculator and you punch this in, right, you will get the following answer. You will get 8854. Okay, in this instance, you used a different formula or different equation and you got to the same answer. Now, you can only use this equation if you have the first and last term. If you've got A and you've got L and you don't want to use that first equation that we used, then you can use this equation. Okay, you can use this equation. Nothing is wrong with using this equation. It's going to give you the same answer. Okay, so this is what an arithmetic series is. You've got these two equations, and you can use either one of the two equations that you want to use to get to your answer. Okay, so this is how you go about solving arithmetic series. Remember, just to recap quickly, first thing you need to do is to establish if what you're dealing with is indeed arithmetic. Is what you're dealing with arithmetic? Is it arithmetic? Most of the time they will tell you that you're dealing with an arithmetic series or sequence. Sometimes they won't. Sometimes they'll leave it up to you to figure out. Is it arithmetic? Is it arithmetic? Okay. In other words, is D the same for all successive terms? If it is, then you can use the equation for Sn and you can use the equation for Tn that we covered in these over the course of these two lessons for sequences and series. Okay, and then you can move forward. They can ask you all kinds of questions. We will solve some of those questions in separate videos. But this is essentially how you would go about solving arithmetic series and sequences. Okay, till next time.